take a look at cotangent function. And in order to talk about the cotangent function, let's first show or recall what the tangent function looks like, okay? So y equals tangent of x would look like this, okay? We have that. And then it's on repeat. Now I'm going to I'll put some scaling on here, so you know what our labels are, okay? Tangent, remember, if you're looking at your unit circle, tangent is y over x. So this is 0, would produce a 0. The tangent of pi over 2 is undefined. The tangent of pi is 0. The tangent of 3 pi over 2 is undefined. The tangent of 2 pi is 0. Okay, and then similarly, in the opposite direction, and tangent now is an odd function, so this is negative pi over 2, and obviously the pattern repeats that way. Now, to graph cotangent, we are going to take all of these tangent values and reciprocate them, right? So for cotangent, all of these y values are flipped upside down. So everywhere there was a 0, it's now undefined. Everywhere there was an undefined moment, it's now a 0. Okay. I'm going to go negative 2 pi here. That was undefined. Now it is 0. Okay. All right. So what does this mean graphically? Well, if you look back at the tangent, everywhere that these values were positive, if you took that number, say it's a 1/2 or a or 1/4, and you reciprocated it, you're going to get still a positive, and the ones really small to 0 or close to 0 are going to be infinitely large. So it's going to come down. Everywhere we had negative values, when we reciprocate those, they're still going to be negative. They're just going to be, if they were close to 0, they would be negative and infinite, right? So the cotangent function looks something like this. Okay. All right. So now what are we doing to this cotangent function? Well, we are going to alter the period of it, and we're stretching it. Those two things. Now, so we're not focusing on that one. We're going to focus on this one. The 5 key points when doing cotangent are going to be asymptote, amplitude, 0, or midline, amplitude, asymptote. Because remember, the cotangent's period is only 1 pi, and then it repeats. So the period here is pi divided by the b value. So this really got compressed horizontally, okay? Now the 3, this is a vertical stretch of 3. So if I'm going to focus on the 5 key points, 1, 2, 3, 4, 5. There's no C, so there's no horizontal shift at all. So it would normally start at 0. It's still starting at 0, and that's an asymptote. Then the restart is 1 period later, which is pi over 4. And that'll be an asymptote. Okay. Now, in the middle of that, we have a 0 or a vertical through the midline, right? The midline for the original cotangent function is there. We didn't have a vertical shift at all, so in the middle here, I will also have that midline value of 0. Now, let's talk about each one of these gaps. So each gap is going to be 1/4 of the period. So basically 1/16 pi. Another 1/16 pi would make it 2/16. Another 1/16 pi is 3/16. Another one would be 4/16, and those could be simplified, of course. This could be simplified to 1/8. All right. Next, midline didn't change, so this will be a 0. Now, normal cotangent has a value of 1 there, but we're stretching it by a factor of 3. Same thing with the one that's below the midline. We're stretching it by a factor of 3. 0 asymptote. It's kind of tricky, but if I make this pi, then this is pi over 2, pi over 4. Holy smokes, that means I'm going to do all of this by a pi over 4. That's kind of a lot and very condensed. And it's on repeat. All right, let's go again. More's going on in this one. Period. Pi divided by pi over 8 will give me a period of 8 units. So this is a horizontal stretch. Okay. Shifting, period shifting, or a phase shift, is C over B. So for us, that's going to be a positive pi over 2 divided by a pi over 8, which is half of 8, which is 4 units to the right. Okay. There is an A value of 4, which means we have a vertical stretch of 4 units. And then we have a D value of -2, which drops the midline 2 units down. Put some labels on here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. 1, 2. All right. Now, if I'm going to do 5 key points, 1, 2, 3, 4, 5. Did I have a shift of my entire curve? Yes, I'm 4 units to the right. So rather than my key point starting at 0, it's starting at 4. The period is 8. So with the period being 8, that means that this is going to restart at a 12. Okay? It also means that each gap is 1/4 of 8, so 2 units large. So this will be a 6, an 8, a 10, and then a 12. Okay? For the cotangent function, it starts with an asymptote. We have a stretch, midline, stretch, restart with an asymptote. So I'm going to have an asymptote here and an asymptote here. Now my midline dropped 2 units. So in the middle, I am down 2 units for my midline. So there's my midline. Okay. So 8, -2 is the midline point. Now, I already know the graph's going to do something like this, right? I'm going to be more precise, though. Let's see. I can always, when in doubt, I can plug in the 6 and see what I get for an answer. There is no harm in doing that, really. But this number right here will be the stretch either up or down from the midline. Same thing here. Well, my stretch was 4 units. So at 6, I'm going to stretch 4 units from the midline. So that's a 6, 2. At the 10 mark, I'm going to stretch 4 units from the midline. That'll be 4 units down, which means this is my 1 period for this function. And I can put it on repeat. Every point will repeat 8 units later. So if I drop this back 8 units, it'll be here, right? If I drop the 10, -6 back 8 units, it'll be 2, -6. And that's that part. This asymptote will be at 8 units back.